Snow are very simple. We've got our rain gauge consisting of the funnel, the inner measuring cylinder, and the large overflow can. What goes with that? The calibrated ruler specifically made for that rain gauge. Then all the other equipment we have is a basic ruler, increments in tenths of an inch, and our snowboard. Some observers will be equipped with just a 4-inch plastic rain gauge. Not quite as big, but the same concept. Funnel, inner tube, overflow can.
Let's look at taking measurements under ideal conditions. An accurate reading of the water content is very important. When the winds have been light, the gauge will catch most of the snow that's fallen. At your scheduled observation time, bring the overflow can inside to melt the snow. The primary method is to melt the snow with warm water. First, pour warm water into the inner measuring tube and measure with a calibrated dipstick. Make sure to note this amount.
1.13 inches.
Then, pour the warm water into the gauge and slosh it around to help melt the snow.
Melting.
Pour this back into the inner measuring tube. Use the funnel and support the tube carefully so none of the contents spill. Measure the total amount and then subtract the quantity of warm water. The remainder is the amount of precipitation for the day. Measure the water content to the nearest 1/100th of an inch. An optional method involves setting the gauge in a bucket of warm water. It may take a little longer to melt. The quickest way is to pour warm water into the catch.
So let's review the measurement of precipitation. One of the most important things we do is get an accurate reading of the water content of the snow. To begin with, you want to get your funnel and your inner tube inside before snow arrives so we can get a better catch. Then, after we've had the snow, we're going to have to bring the gauge inside when it's time for your observation, so we're going to melt the snow. Now you can let it sit there, but it's going to take a long time to melt. So we can either put it in a bucket of warm water, but even then it takes a long time. So what we recommend, because I'm usually in a hurry, I don't know about you, but add water to your calibrated tube. You're going to have to measure that amount so we know how much warm water we're adding. Pour it in, slosh it around so that we get all the snow melted. Then, putting the funnel back on top of the tube, pouring the total back into the gauge. Then, using only this kind of dipstick, the National Weather Service standard rain gauge dipstick, a regular ruler doesn't work. Measuring the total amount, then subtracting out that amount of warm water you added, so then you know just how much water content was in the snow. So then we're in business. Now don't forget, when you're all done, get that gauge back outside so that you're ready to catch your next snow.
Use good judgment. Not only does it matter what and how snow is measured, but it also depends upon the finest details of when and where. The difference of an hour or a distance of a few feet may be as great as taking the measurement in an entire different county. Snowfall is the measurement of new accumulation of snow, ice pellets, and hail, but not freezing rain since the previous day. Place the measuring stick straight down in the center of the snowboard. Measure to the nearest 1/10 of an inch. Double-check your measurement by sampling several places and averaging the totals. After completing the measurement, completely clear the fresh snow and ice from the snowboard and place it back on top of the snow. If you don't have a snowboard, measure on a representative level surface. Remember, snowfall on a grassy surface can actually be supported in the air by the grass, giving unrealistic measurements.
So let's review the measurement of snow. You want to measure it on a snowboard or another good surface like that. Now, if you've got a snowboard in your yard, don't be caught off guard by a big snow. You want to have a flag, something to mark it so you can find it when you do have that surprise snow. Now, if the snow accumulates unevenly, or if you've got drifting in your yard, you're going to want to take a measurement of at several locations and get an average. Measure to the nearest tenth of an inch, and then don't forget, right at your time of observation, clear that snowboard and get it back on the surface of the snow so you're ready for your next measurement.
The total depth of frozen precipitation on the ground consists of the new snow plus any old snow and ice that remain on the ground from previous storms. Report this measurement to the nearest whole inch. This includes the depth of hail, ice pellets, and glaze from freezing rain. Measure the total depth of snow on the ground in an open, undisturbed, and relatively level area free from drifting and premature melting. If necessary, take an average of several readings. With no previous snow and no melting or settling, the total depth of snow on the ground is identical to the amount of fresh snow that's accumulated.
Snow depth is both the old and new snow on the ground, including ice, and you want to measure it right at the time of observation. Take an average if there's variations in the depth, and there often are. If part of the ground is covered with snow and part is bare, you still take an average, including those bare areas. But if the majority of the ground is bare, then all you need to do is report a trace. Do report depth of snow on the ground, even on days when no fresh snow has fallen, and just do your best.
Conditions seldom resemble ideal. Snow melts and settles, and the wind blows. Sometimes snow changes to ice pellets, freezing rain, or just regular rain. Adverse conditions make it more difficult to make accurate, confident observations. The biggest enemy of accurate observations of snowfall and water content is wind. Winds will drift one area and lay another bare. The moisture in the gauge may only represent a portion of what actually fell. Under extreme wind conditions, perfect measurements will never be possible. Precipitation gauge undercatch is often a big problem for open, exposed gauges in high wind conditions.
Two things happen when we've got winds accompanying snow. First of all, obviously we get drifting, and that means we're going to have to take averages of the snow accumulation. But secondly, we've got the problem of gauge catch. When there's wind-blown snow, you're not going to catch everything in that gauge. That may mean the need for taking a core sample.
If winds have been strong and you believe the precipitation in your gauge is significantly less than what really fell, then take a core sample of the fresh snow from a representative location. If possible, take this core from your snowboard. Melt and measure the sample and compare it to the moisture you measured in the gauge. Report the most realistic reading and make note of the source on your form.
So remember, if it's been windy, you may have to take a core sample to get a more accurate reading of the precipitation. Take that sample at a location where the depth of fresh snow is about what the average is for the area. It may be a little bit awkward and difficult to take this reading, but it really does make a difference for the quality of data we collect.
Another factor that makes the measurement of snow difficult is the fact that snow melts and settles. Therefore, measuring snow can be like shooting at a moving target. When dealing with melting snow, measure often enough to note the greatest accumulation prior to melting and settling. The effects of strong winds are obvious and visible, but subtle processes like melting and settling also pose a challenge to weather observers. Depending on temperature, sunshine, wind, and the type of snow, there will usually be a certain amount of settling or melting. When measuring snowfall, the goal is to report the maximum accumulation of fresh snow before it melts or settles. When it's cloudy and temperatures are well below freezing, there may be no melting or settling. But often the snow depth decreases quickly as the storm diminishes or changes to rain.